All right, so linear inequalities means we're graphing a line, and then inequalities are just the greater thans and the less than signs. So we're actually going to shade, because we're either greater than a line or we're less than a line. So it's all the points either above the line or below the line, okay? So for this one, we're already in slope-intercept form, so you guys are pretty good at graphing these. Y, if this was an equal sign, right, we would have a slope of 1/2 and a y-intercept of 1. So the first thing we always graph is the y-intercept, which is at +1 on the y-axis, right? And then we have a slope of 1/2. So rise over run, remember we're going up 1 over 2. Up 1 over 2. Or you can go down and to the left, because negative is also positive. Okay, now we want to check out our inequality sign. If the line is underneath, that means or equal to, right? So if it's or equal to, we can actually be equal to the line. All the points on the line are actually solutions. So if you have the line underneath, we draw a solid line, like normal, okay? If there's no line underneath, we do a dashed line, okay? For just a less than sign, it would be dashed or just a greater than. But since we have the line underneath, it's greater than or equal to, so we want to connect them all the way across. So our solutions include points on the line. All right, then we have greater than. So for greater than, that means that you are going to shade above the line. Some people get confused by shading above and below. So I'm going to teach you 2 ways to do it, okay? So greater than always means shade above. Can you guys tell which way is above on this line? Okay, above is definitely here. All right. This would be above the line. And you just shade. So any solution on the line or above the line should work in our inequality. What I'm going to do is test an easy point just to make sure I shaded correctly. So the easiest point to test is 0, 0. Okay? So I'm going to test this point right here, and I'm going to check if it works. So the point 0, 0, that means I'm going to plug 0 in for y and 0 in for x. So if I plug 0 in for y, I get 0. On this side, what's 1/2 times 0? And then plus 1, 1. Is 0 greater than or equal to 1? No. Okay. So should this point fall in the shaded region? No, because it's not true, right? So if 0, 0 is not in the shaded region, it should be a false statement here. So I'm going to go ahead and erase this because it's not a solution. So I shaded correctly, okay? All right. Go ahead and write that one down. Y is less than 3x minus 1. And draw a separate xy axis for your line. So, Ben, what's the first point I'm going to put on the graph? -1 on the y-axis. Okay, and Aaron, what's the slope of my line? Yep. So it's 3 over 1, which means we're going up 3 and right 1. They're both positive for my slope. So I'm starting at -1. I'm going to go up 3, right 1, put a point. Up 3, right 1, put a point. Or down 3, left 1. Before you go and draw the line, okay? A lot of people mess this up because we get so excited we just draw the line because we're used to drawing the line, right? But you have to check the inequality sign. It is less than the line. Are we including the line in our solution? No. So because there's no line underneath, this is a dotted or a dashed, however you want to say that, line. Okay? So when you draw your line, you want to make it like this, and that means we are not including the line in our solutions. Okay, this symbol right here, what does this say? it says less than. It makes an L. All right, it says less than, which means we shade below the line. Okay, so less than means shade below. Can you guys tell which one is below? Is it over here? Is it over here? Yeah, it's actually this part. But let's test a point and make sure. What's an easy point to test? 0, 0. Now, if 0, 0 is ever on the line, don't test with 0, 0. Pick a different point, okay? So let's test with 0, 0. I'm going to plug in 0, and I'm going to plug in 0. So I get 0 is less than. 3 times 0 cancels, and I have negative 1. Is this true? Is 0 a smaller number than negative 1? Nope. So that means I do not want to shade where 0, 0 is. I want to shade below the line, because that's less than, and this would be below. Okay? What if we have these kind of graphs, like x's and y's, instead of graphs with slopes and y-intercepts? So first of all, we need to remember x graphs cut through the x-axis, and y graphs cut through the y-axis. So for my x graph, I'm going to cut through x, the x-axis, which is here. I'm going to cut through it at negative 2. Okay, and by looking at this inequality sign, is this one going to be solid or dotted? Yeah. Okay, so we've got our dotted or dashed line here, cutting through negative 2 on the x-axis. Now this one we do not have above or below, right? There's no way to do above or below on this one. However, can you guys tell which side is less than and which side is greater than by looking at the x-axis? Yes. Another way to test it is to plug in 0, 0. We only have 0, right? That's it, to plug in. So if I plug in 0, that's the same as looking at 0, 0. Is 0 a smaller number than negative 2? No. So that means I have to shade where 0 is not, which is left of the line. Also, you can tell less than by looking at this negative 2, and all these numbers here on the x-axis are less than negative 2. Okay? All right, now we have y is greater than or equal to 1. So we've got y graphs cutting through the y-axis and Nico solid or dotted line. We have the line underneath, so this is going to be solid, cutting through the y-axis at 1. This one we can definitely do shade above or below. All right, when you've got the y graphs, you can do above or below. So y is greater than 1. Which way are we going to shade? Above. So any point on the line or above the line should be a solution to y is greater than or equal to 1. Okay, I want you guys to write this little chart down in your notes just so you have it.